We've already seen how some sensors provide a range of readings, from a minimum through to a maximum value, such as this slider or this light-dependent resistor. We've also seen how we can use these values along with if-else statements and logical operators to change the way our programs run. Now let's learn how to manipulate or change these values so they operate within a different range, a range that's more useful for our projects. Let me show you what I mean. We know this slider has a minimum value of 0 and a maximum value of around 200. Let's say I wanted this slider to change the speed of my motor. The problem is, the speed of my motor operates at a different range, from 0 up to 100. If I were to use the value from my slider as the speed of the motor, I might be trying to make the motor work at 200% speed, which wouldn't make any sense. So what's the solution? How can I change the values from my slider so they no longer go from 0 to 200, but rather from 0 to 100? Well, I need to use some numerical operators to change each value with a calculation of some sort. Take a look at the values I have available and the values I'm trying to achieve. When the slider is all the way down, it will give a value of 0, and I want a value of 0. When it's all the way up, it will give a value of 200, but I want a value of 100. And when it's halfway, it will give a value of around 100, but I want a value of around 50. We can easily use maths to convert these numbers. All we have to do is halve them. Half of 0 is 0, half of 100 is 50, and half of 200 is 100. Let's look at how we can do that within our crumble. Here I have a simple project where my slider is wired into input A, and I have a motor connected as motor 2. Let's get coding by adding a program start block followed by a forever loop. I think it would be helpful to see what the calculated value is to check that it's working within my desired range, that is, between 0 and 100. To be able to see that value, I need to save it to a variable. Let's rename our first variable calculated speed. We can now set this value by dragging and dropping the let variable equal block and then dragging calculated speed into the first space. So what did I need to do to my values to get them within the desired range? Well, I needed to halve them. To do this, from the operators menu, I'll drag a divide block and drop it here. Of course, when halving numbers, we're actually dividing them by 2, so I'll put a 2 here. So what is it I'm dividing by 2? Well, it's the value from the slider, which is connected to input A. So I'll drag analog A from the input-output menu and place it here. Let's now test our program. As you can see, my slider, which usually gives me values between 0 and 200, now gives me values between 0 and 100. Perfect! If your readings aren't quite within the range that you need, you'll need to experiment at dividing by a different number. But mine's working really well. I can now use this calculated speed as the speed value for my motor. I'll add a motor block and set its speed to equal calculated speed. Right, let's test it again. As you can see, as I move my slider up, the motor speeds up, and as I move it down, the motor slows down. Brilliant! In this situation, it was easy to change my input values to something more usable. I just had to halve them. Sometimes though, you'll need to carry out more changes to the number, so it works within a suitable range. You can always combine numerical operators to create more complicated calculations.